Please use logbook as a required material. Let's go. This is very important to know about what is log before even we understand how to use log. You see, log is a mathematical operator, which means that it is usually used in mathematics. But if you're a science student, then you know that this is not much there in mathematics. Exception is that it is used in applied maths instead of core mathematics. But yes, you learn this in physics and chemistry, and then you apply this mainly in chemistry and sometimes in physics just to solve those very complex questions, complex calculations that you get from those numericals, and that is a very interesting thing we need to know. So first of all, we'll understand that log are of two types. The first type is normal log, and the second one is known as natural log. Okay, natural log is a bit different actually. Natural log is basically having log to the base of e. I'll come to that later, but first of all, you gotta know the relation between them. That is, the relation between a normal log and natural log is that they are having the as the answer. So log e. This e you see is known as Euler's constant. Euler's constant is equal to 2.272 dot dot dot. That is your Euler's constant. Now first of all, before you understand this, we gotta know what exactly are we doing here. Normal log is basically having the log to the base of 10, and if you represent it in the form of this here, we get that this is known as the base. So this is your base 10, and y is basically here your answer, your result, and x is the exponent that you're getting. So from here, when you're applying the exponent on this base, you get the result. But here it's a bit different. You're actually taking the result and the base, and you get the exponent. For antilog, this is just basically the same meaning. You're just taking the exponent here and then getting the value of y. That is very interesting. So basically, if I say log 10 to the power of 100, so how will I write it? I will write it as 2. Why? Because if I normally show it to you, it will be 10 raised to 2 is equal to 100. This exponent is the value I got from here. So yeah, that is how you can actually understand it. Alright, so let's move on to understand on how do we use the log table. And there are methods of even not using log table, but this is very important because we're going to use log table for more accurate problems. I will discuss why. Let's try finding something very easy. This is the main thing many people wanted to wait for, and let's just start it off. So let's do the normal log. Okay, for normal log, we're gonna have the base as 10. Normally we don't mention 10 because it's normally considered to just write it as normal log plain and that stuff, but yeah, you just normally can write log and get the number and value. So let's just start. Suppose I take a random number like 5.392. I don't want to take any sussy number like 69 or 67 or something. But let's go. We're gonna do this. This is not gonna be. Also, I'm not brain rot. Okay, please do not trust me like this. I swear I'm a really safe guy. Okay, so first of all, we're gonna understand what is actually the thing that we're gonna talk about here. Okay, so you see that in a decimal number, there are two places before and after the decimal point. Before the decimal point, we have a number, and this number will be called as characteristics. Okay, you're a human being, you have a really good characteristics, so and I really know that you're capable of many things. You're much capable than this phi here. And then we have the Matissa. Okay, Matissa, it's just representing those numbers coming after the decimal point. So decimal point is like, man, Matissa is literally always ahead of me. I cannot catch up to them. Well, let's see what happens next. Okay, so first of all, we'll mainly go through characteristics and understand what we can do with this thing. What can we play with it? Okay, So as I was talking about here, I actually wanted to discuss that here you take the characteristics. Now this is of only one digit, so take the one digit here and always subtract with one here. So always do that whenever you have a digit. Suppose you had a 53.61 or 62, and then there are two digits, so you will always subtract it with one to get the log value of this characteristics. So you get it as 0. Then what you're gonna do right next here, you got 0, right? So you're gonna put 0 here, then the decimal point. All right, always do this. Now we will look at the first two numbers that we can find this in the decimal, that is 5 and 3. So we're gonna look at the log table. Okay, we're gonna use this thingy so that we can get even more accurate values. We're gonna go here. Okay, now there will be interestingly more really good values you can find here. So we're gonna go to the first two numbers, that is 5 and 3, right? Yes, we got 5 and 3. And then what we're going to check is after 5 and 3 you have to go, we have seen 9 here, so go to the ninth column of 5 and 3. So this is 5 and 3, this will be our ninth column. Should we check that up? Let's just check that up. Okay, we got the ninth column, that is, I guess so, 7316. Okay, it's 7316. But wait a minute, there's this thingy, so this other number, so we will just put it here. Just note this down here. Then after that we have another number, that is 2. So what we're going to do, again take the logbook. Okay, again take the logbook, and after taking the logbook you're going to go to the mean difference part. Now go to 2 and check here which value you will be getting for 5 and 3. You're getting it as 2 here, right? For 2, oh my bad. Okay, this is here. Okay, this will be here, so it's gonna be 2. Okay, it's gonna be 2 here, so we took that 2 here. Okay, so we are gonna take the 2, we're gonna add it with here, so it's gonna be 8, 1, and here 3 and 7. So we got it as 7318. all right, this is the thing. Okay, suppose I want to obtain this value back, so I will take the antilog because I want to remove the log value now. So I will get this value back by just doing it. It's like, you know, you're doing something like this. You first of all apply an operator on 2, that is multiplication operator, that is 4, and then you wanted to make it back, so you're going to do the division, that is opposite to multiplication. So I did that, I got 2 back again. So that's what we're exactly doing here. Okay, and that's how you're going to apply it for calculations. Okay, so we're going to take the antilog. Now for antilog, what you're going to check here is take this number. Okay, take a specific number. Okay, this time it's going to be 0. If it was like 2.36161, okay, I would have taken here 2 and then always add it with 1. Okay, you can add it with 1 and you will get the number here. Now this number will be our in form of digits, so this can be given here in the form of digits, and you will be putting your decimal places based on that. So since I got 1 digit, I will explain what I'm gonna do here. Just keep it here right now. Let's use this and find it in our log table. Now go to the log table. You will actually get slightly same values, not exact value. You will get slightly similar to this. Okay, let's see now. 7318. Okay, where is 73 here? Okay, this is not antilog. Yeah, this is not the antilog. Go to 73. Yeah, this is 73. Okay, we got 73.73. Okay, the first 2 digits. Okay, you can you always start it after decimal number for antilog, and here you can start it with this one and this one. Always remember that, because you know here you can actually see that it's always starting from decimal point. Yeah, it does not make sense for log, but that's how you're actually applying it here. Okay, so here it's gonna be 73, so it's gonna be given here 73, right? 0.73. So first check the number, other number, that is 1. So we're gonna go move to the first column, that is here. So 73, and here it is 5383. 5383. Okay, can you see that? Yeah, so 5383. I'm gonna note this number down again. Now check the number after it. It's gonna be 8. So we got this one. Now go to 0.73. Okay, now check the mean difference. Mean difference here is for 0.73. it was gonna be 10. It's gonna be 10, guys. So take this here and do the same thing here. So you're gonna add it with 10. You get 3 here, 9, and 3 here. Alright, we got this. Now we are gonna just put the values here. 5393. That is point here, okay? 0.5393. Now since we know that it is one digit here, so we're gonna move this one decimal point to the right side one time. So it's gonna be 5.393. And guys, can you check the value of this one and this one? Are they almost similar? There's only small change. Like, look at this, 2 and 3. That is only this one small difference. It's like you're taking this and you're getting 0, 0, 1 difference here. That's it. Like, that's how accurate log is. Yeah, the more accurate you go, there is a small error that takes place. Error takes place everywhere. That's how you're gonna use it, and that's how you're gonna. Sometimes these cases that you get very less decimal points, or sometimes not even get any decimal point. You just get a whole number. So how do you solve this through the logbook? Because if you want some really accurate answers, you can do this. Now if you're doing this without the logbook method, then you directly find the method and you'll get the answer, but this is not that accurate compared to the normal logbook method. So we're going to use the log table method and find the value for a log of 5.2. How are you going to do this? First of all, what you're going to do, check the value. Okay, first of all, go to the mantissa. Mantissa is after this decimal point. Let me just clearly write it down here. Okay, so it's 5. Okay, 5, and that is one digit. So we have one digit. Okay, now always subtract 1 with that digit and you get 0. So what I'm gonna do here, I'll write 0 first and point. That's the first thing I'm gonna do. Okay, after that I will be taking these first two numbers. Okay, so I will use the logbook, and okay, I use my logbook. I get here 52, right? It's 5 and 2 here. Now you will take the first number, because since it hasn't given, because it's 0, you can consider this 5.52 as 5.20. It's fine, you can consider that, and therefore you can just directly write the value as 7160. That is 7160. That's what you can do, and yeah, you get the value of log here. But suppose I have this thing. How do I do this? First of all, check how many. There is only mantissa. There is only characteristics and no mantissa, right? So how am I gonna do this? First of all, you have to check the characteristics part. There is only one digit, negative with 1, 0. All right, I did this. Okay, and what I'm gonna check here next is. I will be doing another one here. Okay, I'm gonna do one here. So it's 0. So 0 point another one. Okay, 0 point other one, and I'm gonna check it here. What is this? 6, right? So go to 60, because you know you can just consider it 6.0. That's why you can consider this as 6.0 actually. So you can just go to 60 and write it here 7782. Okay, go to 7782, and bam, you have written it officially. That's how you write the exponential and the log values. Okay, this is the method. And suppose you get more than more values, like very big values, like here 6.423651, very big decimal values. So of course you're gonna find the log this in logbook, then the column number of this and the mean difference. So you can ignore these two numbers and get the value. That's it. Just ignore these two numbers. Okay, that's it. That's how you're gonna do that. So yeah, I find the first two numbers in the logbook, then I write the column number of this, and then I can and the mean difference, then I can ignore these. It depends upon you. Now for antilog, let's learn something interesting here. Okay, you know, in antilog sometimes there is a chance that you might get negative numbers. Okay, so to deal with negative numbers, it's very important to understand this, because you know there's another way. There's a different whole method for antilog and negative numbers into dealing with this. Whenever you do calculations and you use log method, you will find this in negative sometimes. So how are you exactly going to do this? Because there's a very high doubt based on that. So how I'm going to do here is, in this case, since it's a negative number, I will always subtract it with 1. Okay, always subtract it with 1 and you get -1 here. Okay, Now take this minus 1. I know this is a whole different case, so you take this here, always take the 10 here, and since I got this as the result, I'm gonna put it in the form of an exponent of this 10 base as here. Okay, that's what you will be doing for every kind of negative anti-log here. Alright, I did this. Now what is next is I'm gonna take this whole number, the whole thing. We have dealt with the negative sign. What I'm gonna do here is take this number and subtract it with 0.6321. 0.6321. I subtract it with here. So let me cut this, I get 9, I cut this, I get 7, I cut this, I should be getting here 6, I will cut this, I will be getting here 3, and this 0, so 0.3679, and you will find the anti-log of this number 0.3679, and then you're gonna write the value. So what is the value? I'm gonna perform it for you so that you can understand it again. Alright, so where is 0.3679? 0.3679, here it is. Let's go. We got 7 here. That is 2328, my boys. What is it? 2328. Okay, 238. Okay, that is there. But then 7th column. See that 7th here. So 7th column of which number? 36, right? Oh, wait a minute. Did I mess this up? No, it should be here. My bad. Oh, okay, here. So this is 7th column here, and here it's gonna be 2328 according to me. So by checking out the 7th column, you get 2328 for 36 here. So 2328. Okay, we got 2328. Now we're gonna mention it here, 2328. Now we have mean difference as 9. So check that out. Here it is 36. So 9 is here. That is given here, so this is 5. Take 5 and you're gonna add it with this one. So how much I will be getting here? 13. This one will be 3, and this one will be 3, and this one will be 2. And therefore, my boys, also you might be confused what will be the decimal number. Just take this 0, add it with 1, you get 1-digit number. 1-digit number. So 23333. Okay, take there is a decimal point here, so I will shift it one time because it's 1 digit. So 2.333 into 10 raised to minus 1. That's how you find the anti-log with negative numbers. But what about these numbers that are negative? Because what will be the effect here when I subtract it with 1? What is going to be there? It's going to be negative again, right? So this is easy. What you will be doing here is actually, you know what, let's add another number just to spice it up. Let's say 1. Okay, you can also have it without any decimal number, it's fine, but for now let's just understand. So I have -3. -3 will be given here. Okay, what I will be doing here is go to -3, go here, I take another -1, sorry, not -1, yep, let me check. You -1, you get this as -4. So you're gonna take this 10 again, the result is -4, so its exponent is -4. That is done. Now this one is done, so just take 0.2141 and you're gonna subtract it with 1.0000, and the rest is done by you. You will get the anti-log value of this. Okay, and yep, let me just solve this for you here. Okay, here we go, we get this, and this will be 0, so 0.7859. so try to get the anti-log value of 0.7859, and if you don't know what I'm actually representing, this is anti-log. Okay, this is anti-log. I'm mentioning anti-log. Now there are special rules that you need to know for logarithms. If two numbers are multiplying in log, okay, if you want to take the log of these two numbers or multiplying, you're gonna take here log a plus log b. Okay, or sometimes it could be represented as log into a into b. It can be represented as this, or suppose you just want to take the log, you will put here and this here. Okay, it's fine. Then suppose I have two numbers dividing. What will I do with these numbers then? So it will be by taking the log, I get log a minus log b. Alright, this is how you're going to do it for. Suppose I have a number that is, say, this is the number, okay? I have a raised to b, okay? I have, or say a raised to n. Okay, this is an exponent here. If I want to take the value of log here, what will I be doing? So log a, okay, and this n will come here and it will multiply with this log a value. That's how you do it. But suppose I have n root. Okay, I have an n root. So how am I going to do this? So it's going to be multiply. A is can be, you can write this as 1 by n, right? So in here, when we take the log value, it's going to be 1 by n log a. That's how you're going to use this, because it's important for the calculations part. And yes, also I'm going to give you some questions to do. Try to do this at home if you want to. It's going to be fun. So 5.6432. Okay, try to find the log value, and also try to find the anti-log value. Okay, it's write down in the comment sections. I will like that comment, I will respond to that comment, and I will give a shout out to you if you want to. Okay, I'm gonna subscribe to your channel too if you do this right now. Suppose I have a really complex calculation. Okay, for that complex calculation, I will show you some small steps and how you're actually going to use logarithms in this. So it's only applicable in these kinds of calculations that only require the squaring, or the exponential or multiplication or division or square roots. Okay, it cannot be involved mainly in addition and subtraction, but yeah, that's how it works. But if there is a formula that you can take a part of it and do it. Okay, let me just explain what is going on here. So in this equation, I want to calculate and get the answer. So I can take this square root and write it in the form of 1 by 2. Alright, then I can take this up, I get it positive 7. I multiply this, I got 10 raised to 16. Then I will actually get this much as overall and this one separate. I got this as 10 raised to 8 and this as a separate. And you know that when by following the exponential rule, 10 raised to 16 is actually divided, it was raised to 1 by 2. So therefore I got 10 raised to 16 by 2, that is 10 raised to 8. Alright, so I got 10 raised to 8 from that exponential rule. Now the thing is, you don't need to touch this with log and antilog because it's already solved now. So no need to touch this with log or antilog because it's already solved. But this part is not solved, so this is unsolved. So I'm going to use log and antilog to solve this. So what you will be doing here is, since you're going to use log and antilog, we're going to take this and multiply it with, so that we are applying the log rule. Then you're going to, whatever is getting multiplied, we're going to add it, and whatever is getting divided, you're going to subtract it. Then it remain this untouched. Sometimes you can also calculate this with log and antilog, but you will get the same answer, but it's better not to because it's much easier for you to calculate. That's why once you do this, what we'll get to do is find each and every log value. Now for 70.16, how you're going to do this is take these four first two decimal points. I know that some of the people have been confused here what is going on, so go to log page. Okay, just to example 70.16. okay, I got 70 here and then 0.16. okay, here this is your point here, so this is the first one, 70, so 2 zeros are there. So yeah, I took this 2. okay, I took here 1, then I took here 8457, and by taking 8457 I will be taking the mean difference. Okay, so what is the 6 as the mean difference, right? So where is it exactly? Let's find it out. 6 is here, 4, so 4 is the mean difference. So I take this and I kind of add it, so what happens here is when I add it, I get 1, 6, 4 and 8, so 8, 4, 6, 1. Now this is a 2-digit number, so 2-digit number will be subtracted at 1, so I'll always write here, so it's 1, so I'm gonna write it here as 1.8461. that's how you're gonna do this. Okay, and you don't need to do that, because once you do the log of 10 raised to 8 and once you get a specific value, and once you write the antilog of that specific value, you'll again get 10 raised to 8. So you don't need to do that because it's already solved. Once you do the log of some specific value and then do the antilog of the log you get from the log value, and then you will get the same value back. That's the thing, but make sure it's solved. That's the thing you should know. Okay, next, got all the log values, I calculated, and then I get the overall value. I divided it with 1 by 2, and that is I multiply it 1 by 2, and then I get this overall as 1.5639. I directly will apply anti-log because now I have to change it to the normal value. I have to remove the logarithm function now. So for that, I'm gonna go for the anti-log. I check this out. I get it as okay, it's 1, right? So 1 plus, what I'm gonna do is I'm gonna do 1 plus 1, so that's going to be 2 digits. Okay, remember that, mark that up with 2 digits. Then next is 56, so 0.56. Where is 0.56? It's here, it's given here, 0.56. Okay, so I wrote that here, so it's going to be given as what, 0.5639 something. Yeah, so it's third column, so it's gonna be 0.56 third column, 3656. So I did that. I wrote down the number, then take the mean difference. I got the mean difference as where was it, man? Oh, okay, here it is. And then the mean difference value, I added it with actual 9. Why? Because if you look at this carefully, you will, okay, wait a minute, I think there's something mistake I made here. Did I? Yeah, this is my bad. Should be 8. Okay, should be 8. You will get here 4. So I got 3664 into 10 raised to 9. That's okay, that's the mean difference I got for 9. Alright, I get this value. Now, how did I get it as 10 raised to 9? Just because there are 2 decimal places, okay? 3664, okay, into 10 raised to 8. Now, since suppose this decimal point was here, 2 digits, so it's going to be moved 2 times, so it was 36.64. Now this 36.64, I want to put this decimal place here, so it's going to be 3.664. so you have to also change the value of this one, so it's going to be 10 raised to 9, and that's how you get the value, 3.6649. Now if you want to try it out, try this question. Like say it's 3.21 into 4.27 into 8.3. I'm giving you a much easier value with an exponent of 4. Try this because it's much easier. You will, don't worry, these are the kinds of calculations you will always get in physics and chemistry. So yeah, at first it looks very difficult, but check this out. Okay, if you want to confirm this, I'm going to show a calculator just to show it to that. I did the same thing here. I got it as, I did the same calculation and I got it as 300, this as the value. It is basically in very big value because it's I wrote it in scientific notation. So but you can check from here, it's like 36635. It's a bit closer to 3664, right? That's what it is. So yeah, you can see it from here. Try to solve this. Alright guys, bye.